Hello everyone, my name is Yin Jiang and I'm going to present my project 1 of this semester, and I'm going to make a skin structure of this stadium. This is the Hangzhou Olympic Stadium in China and designed by MBBJ from United States and CCDI from China. So basically it's an ellipsis and copied multiple times and divided into several points and then connect those points to define B-spline curves and surfaces. So I'm going to copy this method and try to figure out how the designer made this in Grasshopper. So firstly, I will show you my first version of this idea, and basically this is the model I created. This is the first attempt I try to make this model, and I create an ellipse, you can see in the bottom, and then I offset several times to create these 5 ellipses, and these are the rings that control the dimension of this model. And I further divide the curves into several points, and so I can use these points to connect and to form these curves and eventually form the surfaces. So firstly, I think, well, I can connect those dots manually. That should be kind of easy for me. So that's basically what I did in the first time. And these are the dots that I manually connected, and these are the curves and surfaces I created manually. So I actually did 24 times on this one because there are 24 leaves, so which result in such huge grasshopper model. But then I think this is not very efficient, though it's easy, but this is not a parametric model should be, and it only allows you to control certain numbers of parameters in here, which is not very efficient, and also I cannot control the number of leaves in this model. So secondly, I create another model, as you can see in here, and I start with the same thing. I started with the ellipse and I offset 5 times, and then I divide them into different points, but after that it's more easy, more simple, and I use this tree structure to let each battery to work multiple times. First I call the, the ellipses into the points that I actually want to connect. Then I manually connect only 2 leaves, and then I use a shift batteries to shift these 2 nodes to the next position. And I have a series algorithm to shift them exactly where I want. So the benefit of it is that I'm able now to control the number of shifts I want, so which result in these parameters that I'm able to create and to control. So let me show you how to control these. So the roof ring size, they are also easy to control, and the highest point you can see here, and the most important thing is I can control the number of leaves here. It's minimum 10 and can go up to 48. Okay, so this model is greatly reduced its complexity compared to the previous one, and I think this is interesting that I can actually control the number of leaves. So for the next one, for the kangaroo force, I baked a 10-leaf model into Rhino, and I just used very simple springs, and first I have to convert this into mesh from Rhino, and then I just use the springs And somehow I cannot set multiple meshes on this one. I cannot set every mesh into this one battery because there are some errors produced. I think this is because they are connected or because something's going on with my Grasshopper model. I cannot do that. So I just copied the meshes multiple times since it is only 10 leaves, so there's only 10 copies of it. And I put the edges as the anchor points, so basically I just make those 10 leaves a 10 tensile structures. So if I actually I toggle it false, you can see just it's a tensile structure. Okay, so lastly, for the force analysis, they are basically the same model, but the only difference is, sorry. So the only difference is I add a color scale here. This is color battery, and I convert the output into edges and calculate the length and let the different lengths multiply by the stiffness of each spring, so the color will change according to the length. So let's see if I change the stiffness, you can see the color changes, and also this can be changed real time. And if I turn on the real-time simulation, and you can see that each spring changes according to the forces it's applied. So this is the force analysis of this model. Okay, so this is my project 1. I hope you enjoyed this video. Thanks for watching.